Okay, now let's discuss IPsec protocol. IPsec stands for Internet Protocol Security. IPsec is an open standard that enables secure and encrypted communication. Open standard means almost all firewall, checkpoint, Palo Alto firewall, FortiGate firewall, Cisco SA firewall, FTD, all the firewall and routers support this protocol. So it means you can configure site-to-site VPN using IPsec between different router and different vendor firewalls. It can be from checkpoint to Palo Alto firewall to FortiGate firewall, whatever the combination. If they support, you can configure and you can use IPsec protocol because it is an open standard. Now this IPsec is a suite of protocol, as a complete package to provide you confidentiality, integrity and authentication. I believe in second lecture we discussed CIA, confidentiality, integrity and availability. So we discussed these three things there as well. So they can provide you these three main things: confidentiality, integrity and authentication. And you can use IPsec for both type of VPN, remote access VPN and site-to-site VPN. So you can use IPsec to build VPN over internet on other non-secure network, because this is the purpose to use this protocol. If you are using unsecure network such as internet to securely access your resources, so it means this protocol is for you. IPsec Internet Protocol Security work on network layer. So this protocol work on network layer differently. This is the security for IP, and IPS work on network layer. IPsec only unicast traffic can pass through virtual private network. It means if you are using multicast traffic, so IPsec is not for you. This is the main disadvantage of IPsec. But mostly we have unicast traffic, then you can use IPsec VPN. So you can use IPsec to encrypt and authenticate between two different devices. It can be firewall to firewall, router to firewall, or whatever. It can be the combination. So IPsec is a framework that helps us to protect internet protocol traffic on the network layer. So it will provide the security for IP on the network layer. Now these are the four features of IPsec. Confidentiality. Confidentiality means encrypted the data. So nobody except the sender and receiver to read the data is called confidentiality. When you encrypt the data and send to the receiver and receiver can see only, so this is called confidentiality. Encryption algorithm protect this data so that it can be only read by sender and receiver, and nobody in the middle can read this data. So we need and we use confidentiality. It means the data will keep secret using encryption algorithms such as DS, 3DS and AES. We can use these different algorithms to encrypt the data so that nobody can see and nobody can read them beside the sender and receiver. This is the first feature which provided by IPsec. So when you have a site-to-site VPN, there is internet which is unsecure, so you can use the feature of IPsec to provide you confidentiality to encrypt the data and send from one device to another device. Second feature which can provide you IPsec is integrity. Integrity means that nobody can alter or change the data when the data is in the motion. When you are sending the data from one location to another, from one device to another, from one firewall to another firewall, so nobody in the middle can alter, change and modify the data. So for that purpose we are using integrity, and this integrity feature can be provided by IPsec as well. So this is the second feature provided by IPsec, and I show you integrity. They are using two algorithm which is commonly used, MD5 and SHA, and we discuss this in detail in hashing. So basically that hashing can be used by integrity, and integrity is the feature of IPsec. They can provide you integrity as well. So by calculating the hash value, the sender and receiver will able to check that the data is not being altered and nobody changed the data when the data was in motion. So this is the second feature of IPsec. Third feature which can provide IPsec, authentication. Authentication means both devices will authenticate each other when they are exchanging the data. They will verify the data integrity and authenticity of the message. First they will check it is you, they will send, and they will verify this receiver. This is called authenticate, to verify the person, the device. And they can use for authentication pre-share key, and it can be a certificate as well. The IPsec receive can authenticate the source of the IPsec packet sent, and it means we need to verify. So verification and also done by IPsec. The fourth and last feature of IPsec is anti-replay. One type of attack is attacker could try to capture these packets and send them again. Even though they cannot read them, but they can capture them and they can send them again. Or maybe they duplicate them and intercept them. They change them, they duplicate them, they change the sequence. So what the IPsec feature is anti-replay. What they will do, if the packet is arrived late and it has been modified, or it has been duplicated, or it has been captured and it been received later, it will be considered alter or it will be dropped. So 1, 2, 3, 4 and somebody capture packet number 3 and it's arrived later than 4, or it has been duplicated. So what they will do, they will drop them, that no. So somebody can do such type of attack. So IPsec can provide you protection from such attack as well. So it's a complete suite providing you each and everything which we need for VPN. Now IPsec has two main protocol, ESP and AH, and there are many encryption method. Most one is DS, 3DS and AES. There are two type of authentication, MD5 and SHA. And there are many DP element which we discuss in detail, D1, D2, 5, 14, 13 up to 30. There are many DP element group which you can use. Now the two main protocol which is used by IPsec is encapsulating security payload, which we call them ESP. Now if you are using ESP in IPsec, it can provide you integrity, encryption, authentication and anti-replay function as well. All four features which we discussed above, if you are using the IPsec protocol ESP, they can provide you all four facility and features. They can use DS, 3DS and AES to encrypt the data. They can use MD5 and SHA to generate the hash of the value, and they can use pre-share key and certificate to authenticate. And there is an extra feature, anti-replay, if you are using ESP and IPsec protocol to protect you from duplication of the data as well. So ESP encapsulating security payload provide you all the IPsec features, so which is a good thing. Also keep in mind that ESP use IP protocol number 50. In next video I will show you, when I capture and Wireshark, I will show you protocol number 50. Also I will show you integrity, encryption, authentication and anti-replay related to ESP. Also, another advantage to use ESP, it can be used for NAT as well. If you are using side-to-side VPN and there is a router or layer 3 device which netted your IP, so still you can use ESP. So they can provide you this feature as well. Now, encapsulating security payload protocol support 2 mode. By the way, both the protocols support both mode, transport mode and tunnel mode. And transport mode is use original IP header and insert new ESP header. If you are using transport mode, if you are using ESP and transport mode, then it use the original IP header and insert new ESP header. So this is original IP header. Original IP header is here and they insert a new ESP header, which is this one. This is the only difference if you are using ESP and transport mode. But if you are using ESP and tunnel mode, it use a new IP header which useful for side-to-side VPN. But if you are using in tunnel mode ESP, then it will create a new IP header. Here they are using the original IP header and insert they put their own ESP header. Here even though they put their ESP header, but they create a new IP header and the original IP header is there. This is the only difference if you are using ESP and transport mode and tunnel mode. Now let's go to the other protocol which you can use in ISP, which is Authentication Header. Authentication Header can provide you data integrity and authentication plus entry replay. But unfortunately, Ipsec, if you are using Authentication Header, it will not provide you data encryption. So it means this was providing encryption as well. This is the only difference, the main difference between ESP and AH. AH can only provide you data integrity and authentication but no data encryption. It means the data will not be encrypted. And data can be tampered and it can be seen by other. And it used protocol number 51. This was using protocol number 50. Now coming to NAT, so Authentication Header does not work with NAT. If there is a native device between your two sides, so you cannot use Authentication Header. So Authentication Header does not use NAT, Network Address Translation Traversal. Authentication Header AH protocol support also transport and tunnel like the above one, ESP. And transport mode simply just add AH header after the internet protocol header. So this is the original IP header, TCP header and data. And if you are using in transport mode, this is AH transport mode. So this is the IP header and they put their own AH header and rest of the data is similar because simply just add AH header. That's it. But when in tunnel mode, add a new IP header on the top of original packet. But if you are using them in a tunnel mode, so they will create a new IP header and then there will be AH header and then the original packet. So this is the difference between similar difference like in the other one. Now Ipsec mode. There are two modes of Ipsec, tunnel mode and transport mode, which we discussed above in both protocol. In tunnel mode, the entire packet is encrypted and authenticated by Ipsec. Tunnel mode is the default mode in most Cisco devices. The packet is encapsulated from a new IP header information. And in Ipsec tunnel mode, protect layer 3 and upper layer data. Normally we use Ipsec tunnel mode and side-to-side VPN, remote access VPN and get VPN. Tunnel mode is more secure and encrypted both the header and payload. Above we discussed. You can go through them again. So you will get the idea. It will generate a new header. Tunnel mode is used to encrypt traffic between secure IP security gateway. Normally we use this tunnel mode between the devices, the main devices, means gateway, such as router, such as firewall, which is on the edge. So normally, and after the edge, the data is not encrypted. So in that case, we are using tunnel mode of IPsec. So this is R1 branch 1, this is branch 2, and they have a router. So we are using IPsec tunnel mode we are using to encrypt the data. And after this, the data will not be encrypted and they can reach to each other. And this is the internet, so we encrypt the data. So in that situation, if you have a gateway, you have a firewall, and you want, so then in that case you can use tunnel mode. While in transport mode, IPsec only encrypt and authenticate the actual payload of the packet. In transport mode, the header information remain unchanged. This is the things. It means your original information are unchanged, the header information in your IP header. IPsec transport mode is used for end-to-end communication. We are using this for between client and server. Communication between two workstation, two server, client and server, such as to encrypt telnet or RDP session. And IPsec transport mode protect layer 4 and upper layer data. And IPsec transport mode is use original IP header. Original IP header will be visible. So IPsec transport mode used when another tunnel protocols GRE is used. Yes, in that case. And also in dynamic multi-point virtual private network. And maybe you have a server and client and you want to encrypt RDP, or maybe you want to encrypt the telnet session. Then in that case you can use transport mode. And this is not between the edge devices, this is between the two end devices. So this is the difference. This was between two edge, or this edge firewall can be a firewall, it can be a router, it can be a router and firewall, it can be any combination. But here these are the end devices. So in that case we are using transport mode. Finally, an IPsec has authentication, hashing, integrity. So we already discussed MD5. You can use MD5, message digest algorithm 5, which produce 128-bit hash value, and second one is SHA, which we discuss in detail, secure hash algorithm, and SHA has many flavor. You can use these two for IPsec authentication or integrity. And for IPsec encryption, you can use DES to encrypt the data so that nobody can read them between two parties. So you can use DES, which is the old one and which was developed by IBM in the year 1970 but later adopted by NIST. Data encryption standard key length is 56-bit and block size is 64-bit. So it means it is less secure as compared to other, and it was cracked many times. So better not to use DES to encrypt and garbage your data from clear text to ciphertext. But this algorithm is there to use for IPsec encryption. Second one is 3DS, which is the advanced version of DES. DES to encrypt the data 3 times. In 3DS, data encrypt standard encrypt is applied 3 times to the plain text. Plain text is encrypted with key 1, then decrypt with key B, and then encrypt again with key C. This is the procedure to make them more secure. So this is the advanced version of DES. So triple DES is also support encryption protocol for use in IPsec and Cisco product and many other products as well. The triple DES operates similarly DES. Their data is broken into 64-bit block. So block are similar, but 3DS process each block 3 times, each time with independent 56-bit key. So it means triple DES effectively double encryption standard over 56-bit encryption standard. and triple DES is variation of DES, which is secure than data encryption standard, which is more advanced, and it will do the encryption 3 times in simple word. And the final one is AES, Advanced Encryption Standard, which is far better than the above two, which you can encrypt the data, and it was developed in the year 1998, and this is a new and a stronger encryption standard. Firewall can use AES to encrypt using 128-bit, 192 and 268, 256-bit. And normally we say AES 128, AES 192, AES 256. Depend on the key length. So you can use this the advanced way to encrypt the data. It is more secure to transfer, to convert your plain text to garbage data. We can use these methods AES, 3DS and DES. These are the encryption. Encryption means to convert, we already discussed. And these two are the hashing algorithm. Most probably and better to use SHA. And then we discussed two mode of IPsec. Transport mode, which is end-to-end, and these are between the gateways, and tunnel mode. Also we discussed them here, and also two protocol which we can use: IPsec, Authentication Header, and ESP. And ESP is better to use if you are using site-to-site VPN. And these are the things which we discuss: ESP and AH encryption, and also authentication, and DP-Hellman we discussed separately. So this was IPsec, which can provide you a complete package of everything to use them and to securely transfer your data from one device to another, from one site to another.